When you search a map for the nearest place, the system cannot measure every point one by one. A KD tree is a data structure that divides a 2D map into small regions we can quickly rule out. A map database stores hospitals, clinics, and fire stations as 2D points. With more points, brute force scanning gets slower and slower. Which one is closest? The most direct way is to measure the distance from your location to every single point. Each measurement is one comparison, giving ON. 1 million points means 1 million comparisons. The more points there are, the longer this red bar grows. Oh, exactly the problem a KD tree is built to solve. To build the tree, choose the median on the x-axis and draw a vertical line, splitting points into left and right halves. At the next level, switch to the y-axis. Each half gets a horizontal split. Every level alternates between x and y. Repeat this process, and the map becomes small, bounded regions. Each leaf keeps only a few locations. Every split becomes a node in a binary tree. The root stores the first X split. The left and right subtrees represent the map's two halves. The next nodes, story splits. Leaf nodes hold only a few candidate places. A KD tree makes spatial partitions correspond directly to a tree index. For the nearest place, first descend toward the side containing the query point, here into the right half of the map. At the leaf, compare E and G in this small region. E is directly below the query and closer than G to its lower right, so ambulance E becomes the current best. Then we backtrack. At each split line on the path, compare the query's distance to that boundary with the current best E. Whenever the boundary is farther than E, the entire subtree on the other side cannot be closer, so it is pruned. So we visit only a few partitions instead of all endpoints. In low dimensions, with a balanced tree and well-distributed data, average query cost is often close to O log n. The worst case can still degrade to ON. KD trees build spatial indexes through alternating coordinate splits, generalizing from 2D to any k dimensions, and powering nearby map search, collision detection, and point cloud queries.